So I will just give you an idea where the container component is used at the moment. Beside of our container application, there are also some other standalone tools, like the DTM inspector. DTM inspector, you know what it is used for? The certification tool for FDT1 DTMs, but also the custom systems with a user interface or just a command line or whatever. Based on the FDT container application, we have remote access application running. Maybe you have noticed this kind of presentation styled application running on the iPad in the other room. It's also a standalone tool based on the FDT container component, using some parts of the container application to present topology and project information. We have a FDT container OPC server, and there are also some OEM FDT container frames we brand label for some of our customers. So to finish the introduction, a look on the API, on the architecture of the container component. The container component is provided as an interface named iRuntime frame. This is also why a lot of people are talking about the runtime frame. It's just the name of the interface of the container component. It provides the object model root. It provides the functions that could be used with this runtime frame, like starting up and shutting down this complete component. It provides the functionality to configure the component, like the threading model, the limited number of started DTMs, which may be very interesting to minimize or to control the memory consumption. Directory paths. We will see in the preparation for the frame implementation that it is necessary to do some preparation that this is running, that I can integrate the container component. And some timeouts. Maybe you would like to shut down the project, and you have set a DTM online, you have a user interface open, something like this. There is a job running, and you would like to shut down the application. So DTM is busy. Would you be done? This is where some timeouts are used to finally tell the user, would you like to force the shutdown? Would you like to force removing the communication channels? Things like this. These are all parts that are built in the runtime frame. It also gives you access to the DTM catalog and all the other parts that are built in here. So creating, opening projects, all these standard workflows that we have in a FDT application are accessible via this iRuntime frame interface. The DTM catalog gives you access of the DTM catalog, of course, which DTMs, which device types are installed. The registration information, The registry was one question in one of the presentations before. This is scanned by the catalog, or when building up the catalog, and also the manifest files are scanned to see what's installed on the machine. So there are some necessary functions for the DTM catalog. Of course, update it. Have a look whether there is something new, rebuild it completely, save it, execute some queries. Maybe it's necessary to just have a look on all the DTMs that are just speaking one protocol, which are the Profibus DPV1 DTMs, which are the communication DTMs providing Profibus DPV1. There are several queries. You can reduce the information from the catalog. The catalog entries are version independent, so it makes no difference whether this is a FDT 1.2 or a FDT 1.2.1 or a FDT 2 DTM. They are all stored in the same way. Maybe they are not providing the same amount of information, but they're still stored in the same way. So the frame project, which is embedded in the runtime frame, embeds some interfaces by itself. It provides information for the DTM data, for the functions, the topology of the DTMs. Some necessary workflows for the project are to save it, shut down the project, all DTMs, close the project itself. And inside of the frame project there is a DTM list, which is the flat look on the DTMs. There's the topology, which is the hierarchical view on the DTMs. It's also providing the proxies. DTM list of all contained DTMs, gives information about what kind of DTM is it, what name has the DTM. All this data set information could be read from the DTM list. And the topology, as I said, is the hierarchical view on it, which is connected to each other. Necessary functions of this are, of course, adding a DTM and removing a DTM and building up the chain of them. Also the validation whether adding or removing is okay or not. And if you think about these communication channels, it's also up to the topology to register or unregister communication channels. So it provides information about all nodes, some kind of flat view or the root nodes, or some events that are triggered during adding or removing a DTM. And it also supports the mixed topologies, which are interesting when we think about FDT2. With the frame common component, you can build up your environment just containing FDT 1.2 DTMs. It's also possible to build an environment just with FDT2 DTMs, but it's also possible to build a mixed topology with a FDT2 COM DTM and the FDT1 device DTM. And the proxy finally provides you the raw IDTM pointer and lets you access information about the modules which are built in, about the current DTM state and device status and things like this. Network information like bus address, instance data, process data, all these are the information you get via the DTM proxy, depending on the device type, which is represented by the DTM. So features like going online, going offline, upload, download of parameters, things like this. Hardware scan. For all of these functions, there is an API. We have a help file, we have a IntelliSense support if you try to build up your own frame application based on the FDT container component. We will have a look on some of the definitions of one or two functions to see what's described in them, to get an idea whether I need to bother about a possible exception. It could be very interesting.